Hello friends, so today we're gonna discuss this question from Lead Code Weekly 171, problem number 1318, minimum flips to make A or B equals to C. The question statement is very simple. It states that you are given three numbers A, B, C and you have to return the minimum flips which are required such that A and B, the OR of A and B is equal to C. Okay, let's see the example to get a more insight on this question. Uh, as we can see, A in the bit representation is equal to this, and B equals to this, and C equals to this. Okay, if we do an OR of A and B, what we get is a 0. Okay, because 0 and 0 OR is equal to 0. But we want to displace an OR of a value of 1. So if we just flip any of them, it will become 1. In this case, we want a value of 0 in the C, but both of them has 1 as a value. So we have to flip both, because if any of them remains as 1, it will again give a value of 1. As I hope you know bit or how to do bit or. Okay, so what the main basic function are, there are four cases. Let me take you. If both are 0, if both of the bits of A and B are 0, then the answer will be 0. And if we want a 1, in that case, what we can do, we can change any one of them to 1, and then our when we do 0 with 1 or, the answer will be 1. So in this case, we just want to make any of that number equal to 1. If any of one of those number is 1 and other is 0, the bit OR is equal to 1. But if our C has 0, we have to make this number equal to 0, such that now the OR of these two bits equal to 0. So again one more operation is required. In the same case, we have to make this 0. So one flip is required. But in this case, if both of them are 1 and we want a 0, we have to make both of them equal to 0. So in this case, two flips are required. So we just have to check in both A and B at a given position, at a given bit position, which of these four conditions is satisfied. And then we have to just count the bits, well, the number of flips required. I've just written down this code. I'll move from A to 0 to 32 bits, and I'll store XYZ as the position of that bit from the ith position from the left. And as we can see, if I have also told you of all the four cases, and I've also written in the comments how we are taking all those four cases. In this case only, we are taking plus 2, total plus 2, and in all other cases we are just adding total plus plus, and then after it we'll just return out the output. As we can see, if z equal to 0, z we are depicting is C. I'll just tell you one case. Like in this case, A and B has its ith bit equal to 0. So if A and B both has that ith bit equal to 0 and C is not equal to 0, as you can see in this case, C is not equal to 0 and both A and B are equal to 0. So just we have to make one of those equal to 1 and our case is solved. So one flip is required. So total plus plus. If A and B of the ith bit is not equal to 0, both of them are not equal to 0, and C is equal to, and the ith bit of C is equal to 0. So we require two flips, and same for these two cases. That's it. We just increment the total whenever we encountered any case, and then we return the final output. I hope you understand the logic. Thank you for watching, and I'll see you in the next one.